top. And our problem is a marauding horseback archer fires an arrow at a castle, and he's on a height of 2 meters because he's on top of a horse. So he fires and he starts at a height of 2 meters. And the arrow comes out with a speed of 50 meters per second and an angle of 25 degrees above the horizontal. So he starts at a height of 2 meters, speed of 50 meters per second, and an angle of 25 degrees above the horizontal, all for the arrow. The castle walls are 80 meters away. He's firing it at a castle, and the walls of the castle are 80 meters away, and they're 10 meters tall. How far above the wall is the arrow when it flies over? So let's draw a little picture. So we see our man. He's on horseback, but I won't draw the horse. And there's castle walls out here in the distance, right? And so there is a distance of 80 meters between him and them, and the castle walls are 10 meters tall. So he fires an arrow. He fires an arrow, and it flies through the air. And the question we want to know is, just as it gets above this wall, how tall, what's the extra height above that wall? How high is the arrow above the wall? And then it will wind up landing on the other side. Hopefully it won't hurt anybody. Well, he is a marauder. Okay, so let's see, how can we figure this out? So our first question is, when is the arrow above the wall, right? We've got this great formula here. We can figure out what the height of the arrow is if we know the time, because we know what V0 is. It's 50 meters per second, right? We know V0 equals 50. We know theta equals 25. He fired it at an angle of 25 degrees above the horizontal. We know that its starting height was h equals 2. And we were given g, so that's everything that we need for y except for the time. But we don't know what time it is before it manages to make it over those walls. So what we need to do is we first need to figure out, when does it make it to the walls? At what point is it at the walls? So x equals v0 cosine theta t plus d. So we know what v0 is. It was 50. We know what theta is. It's 25. We know how far they are, so we know what our x value is going to be. It's 80 meters away. So finally, what is our d? That's the one thing we don't know there, right? So what's the d? Well, let's just say that the horseback rider, where he starts, is 0, right? We might as well make his horizontal location 0. So he starts at 0 horizontally. So 0 equals x here, and then this is 80 equals x here. So the castle walls are at 80. He starts at 0 in terms of horizontal x location. So at this point, we're ready to solve this thing. So in general, we have that x, for any horizontal location, x is equal to 50, our initial speed, v0, times cosine of 25 degrees, times the amount of time that the arrow has flown, plus our initial location. Our initial location was 0. So at this point, we want to solve. So at x equals 80, our time is equal to what? So we plug in 80 equals 50 times cosine of 25 degrees, all times time. We divide by 50 times cosine of 25 degrees, so we get t equals 80 over 50 times cosine of 25 degrees. We plug that into a calculator, and we get that t is approximately equal to 1.765 seconds. So after 1.765 seconds of flight time, the arrow is now at the horizontal location of the walls. So after 1.765 seconds, we are at the walls. So now we can plug that in and we can figure out, once it makes it to the walls horizontally, how high up is it? What is the arrow's height once we are at the walls horizontally? So now we use y. Y equals negative 1/2 times 9.8, so negative 1/2 times 9.8, our acceleration due to gravity, t squared plus v0, so 50 times sine theta, sine of 25 degrees, all times time, plus our initial starting height. Our initial starting height was 2, right? Because he fires it from the arrow, fires the arrow standing. He's, on top of a horse, so he's firing it from above the ground. He's not firing it from actually the level of the ground. So we will start working through that. We want to plug in at time equals 1.765 seconds, because that's the time that we're interested in knowing the height. So we plug that in here. We plug that in, and we get y equals negative 1/2 times 9.8 is negative 4.9 times 1.765 squared plus 50 sine 25 degrees times 1.765 plus 2. Kind of a lot there. But at this point, we can work this all out. We work it out with a calculator, and we get that it is at 24.03 meters high. So the arrow is 24.03 meters high when it gets to the walls. However, that's not our answer. We were asked how far above the walls when it gets to it. So how far above the wall is it? So at this point, we take 24.03 minus the height of the walls is 10 meters tall. So minus 10 will give us the amount that it is above the wall. So that comes out to be 14.03 meters above the castle walls when it flies over them. All right. So that finishes up for parametric equations. The important part is to think about it. It's describing the motion of an object in terms of this time. So try to think about it as how would time change x, how would time change y. Try to think of both of those together, and you'll start to slowly build up a sense of how parametric equations work without even having to graph them. Mainly, experience is a great way to learn how to do these things, but you can really speed up the process of learning and understanding parametric equations by just playing around honestly for 5 or 10 minutes with a graphing calculator. Just playing around, screwing around, plugging in random things and seeing how one thing affects another thing, how changing one constant causes things to move around. Just playing around for 5 or 10 minutes will help you so much more than trying to do like 10 graphing problems. All right, we'll see you at Educator.com later. Bye.